Good morning. Today we are going to be looking at chapter 2 of the textbook. And if you look at the chapters that we need to look at in the textbook, please take note of this as well. So the first 8 chapters of the textbook, the assumption is it's things that you should be familiar with that you would have covered when you're doing your undergrad. Because if you look at these chapters, chapter 2, chapter 3, chapter 4, chapter 5, and part of chapter 6 as well, you would have been expected to have done this in Fin4801 if you're studying with UNISA. So you would be expected that these ones, you should be knowing them because you have encountered them when you're doing Fin4801. Then chapter 6 as well, chapter 7, and chapter 8, you would be expected to have gone through this when we're looking at chapter Fin4701. So you will see that chapter 6, it also comes valuations. It's introduced in Fin2601, and it's also dealt with in more detail when we look at chapter Fin3701 as well. So you will see that the first 8 chapters of the textbook, if you have a good background of things that you have done at undergrad level, Fin2601, Fin3701, it might feel as if Fin4801 is easy because these first 8 chapters, we are reviewing things that you are assumed to still remember from what you've done at undergrad level. But the reason why we still need to go through this material is because we know that it's not everyone who still remembers things that they've done at undergrad. Because normally students, when they graduate, they seem to erase a lot of the things that they've learned. And then, so which means that at honors level, we need to make sure that you are understanding the foundation, because you are not going to be able to understand chapter 9 going onwards if you don't have a good foundation of things that you assume to be having known when you're doing your undergrad. So you need to be having a good background of things that you should be. So which means that for you to make sure that you fully understand these concepts, that's why we are going back to these chapters again. Then, so today we're going to look at time value of money. And looking at time value of money, you need to be using your financial calculator. So your use of the financial calculator is going to be very important here. Whether you're going to be using the HP calculator or Sharp calculator, it doesn't matter. We give you practice questions based on those as well. So today we're looking at chapter 2, which looks at time value of money. But remember, time value of money forms the basis of the other chapters that we're going to be looking at, especially when you look at chapters 6, 7, and 8. Time value of money principles are going to be coming in as well, mainly because valuations and capital budgeting, you're going to be looking at valuation, you're going to be using the time value of money principles as well. So although we're going to introduce you to the formulas that you are expected to have learned at undergrad for time value of money, we are going to be concentrating more on the use of the financial calculator than the formulas, using the formula, because it's quicker if you use the financial calculator, because some of the calculations that we're going to be doing are going to be using the financial calculator as well. And remember, in the exam, even if the steps that you're taking using the financial calculator, write down the steps that you're taking even with your financial calculator, because what the lecturer always emphasizes when it comes to the exam is show as much of your working as possible. So that if you are, the more working you are showing, the more they are able to understand where you are coming from and where you're going with your calculation. And also, if you show more of your working, it basically means that even if you are now sitting with about 49% overall mark, the lecturer is able to now push you to get a pass mark, because they can now, try to be lenient with you as well. But if you're not showing any working and they're showing limited amount of work and you're just showing the final answers, it's difficult for them to be lenient with you. And it's difficult for them to also understand where are you going and where are you coming from with your calculation as well. So remember, if you have a good background of things that we have done at undergrad, chapters 1 to chapter 8, it might feel as if Fin4801 is easy, but it's not easy, because chapter 9 onwards, we are now going to be looking at in-depth analysis of financial management as well. So which means you are now, from chapter 9 onwards, that's when you're now looking at it from a higher level. That's when you're now going to start looking at it from what? A postgrad level as well. And please take note, from chapters 1 to chapter 8, the principles that they bring to you, or the different variations of formulas that they bring to you, or the different concepts that they bring to you, which you didn't really cover in Fin2601 and Fin3701, don't worry much about them. It's just different variations, but the lecturer doesn't emphasize much on that. But I'll also highlight you to say, this, don't worry much about this formula, because you'll see that your textbook is also going to be bringing in a lot of different variations of these concepts as well. Are there any questions so far before we start? Any questions? Please make sure that where your device is, you have a good internet connection as well, so that you're able to hear properly what we are discussing as well. And also, please make sure that you always put your devices on mute as well. So always make sure that you put your devices on mute. Unless if you have a question, then so that if you have a question, you unmute, you answer your question, then you can put it back on mute so that I don't have to hear the interference in the background as well. So looking at chapter 2, we are looking at time value of money principle. And if you look at time value of money principle, if you have studied financial management or investment management at undergrad, you see that these principles, they are very much relevant as well. But remember, we need to go through this step by step so that there are also other students who are now doing their honors and they need to do financial management, but they don't really have a good background when it comes to financial management as well. So we need to make sure that they also benefit from this practice so that there's no, we are not going to end up disadvantaging anyone. So looking at time value of money, they say under the introduction, in this chapter, we will learn how to value estimated future cash flows and apply time value of money principles to such applications as determining the repayments on the loan. So the principles outlined here are fundamental to all aspects of financial management and serve as essential tools in the activities of the financial manager. So which means we're basically saying time value of money principle, you are going to be seeing it being applicable even when we look at other chapters and concepts as well, because it basically forms the foundation of the activities that the financial manager is going to be embarked on, whether it's investing activity or financing activity. So when you look at time value of money, we are going to be, the first concept that we're going to be looking at is the concept of the future value. So here they say, investors expect to receive a return on their investment in the form of interest and other returns. So we need to increase the original amount invested by adding the interests that accrued during the time of the investment. So the future value is the value in rent that an investment or series of investments will grow to over a certain time period and specified interest rate. So the following notation will form the basis of your formula to be applied in the chapter. So when you look at your financial calculator, you will see that on your financial calculator, there's going to be the FV, which is basically the amount of cash which will have accrued by a given date resulting from earlier single or periodic investment. So the future value is basically the value of money sometime in the future. Then there's the present value, is the value of investment at the beginning of the period, and sometimes referred to as the principal amount. then R is the interest rate. And you see that, well, on your calculator, if you're using the sharp calculator, that's basically on the top buttons there, the button written I/YR, or the button written I, or the small letter I, that's basically the interest that they're going to be entering. Then there's also the annuity payments. Whenever you're dealing with annuity payments, that's the PMT button on your calculator. And then they say these are the periodic investments or installments made, excluding single lump sum investments. So they may occur at the end or at the beginning of each period. If they're occurring at the end, that's a normal annuity. And if they're occurring at the beginning of each period, that's an annuity due. Then there's also the end, which reflects the number of periods for which the investment is to receive the interest as well. So example 2, they give us example 2.1. Can you quickly read through the example 2.1 and we'll go through together? So here they say, we're looking for the future value after 1 year. So here they tell us that the amount of 100 Rand is invested for 1 year at an interest rate of 12%. So what is the future value of this investment? So to find the future value, I'm going to show you using the formula, but remember, we are going to steer away from using the formula because in the exam, as we go forward, we're also going to be concentrating more on using what the financial calculator. So here they say the future value is given as the present value in brackets 1 plus R to the power of T. So T in this case, sometimes they refer to it as N. So if they say to the power of N, it's basically the number of periods going into the future or the number of years going into the future. So in this case, to find the future value, it would mean the present value is the single lump sum amount which is being invested of 100 Rand in brackets 1 plus the interest rate. The interest rate, if you're using the formula, the interest rate has to be entered as a decimal. So if you're going to be using the formula, the interest rate has to be entered as a decimal. So 12% interest as a decimal is going to be 12 divided by 100 to make it a decimal. So 12 divided by 100 gives you 0.12. And this is going to put the power of 1 because it's after 1 year. So if you do the calculation there, it would mean if you're using the normal scientific sharp calculator or the scientific calculators, you can put everything one and one to get the answer. You're going to say 100, you open brackets, 1 plus 0.1, close brackets, any number to the power of 1 is that number, so it won't make a difference. And then you get your answer. So you should be able to get an answer of 112. Are we on the same page? Any questions? Anyone lost? I'm not going to spend too much time. If you're lost, please let me know. I'm trying to avoid spending too much time on principles that some people might end up feeling like it's what? A bit of a drag doing the same thing that they already know over and over again. So remember, this is your FB, this is your present value, this is your interest rate, and this is the number of periods going to the future. So in this case, we're going to say, if you're going to be using your financial calculator, let's look at the rules of using your financial calculator. Rule number 1, always clear memory unless data entered is still relevant. So always clear your memory unless the data that has been entered is still relevant. How do you clear your memory? If you're using the sharp calculator, so if you're going to be using the sharp calculator, to clear your memory, I'm going to say second function alpha 0, 0. Second function alpha 0, 0. It means you've cleared. That's basically how you clear your memory from your calculator. And if you're using the HP calculator, you're going to say shift. So you press the shift button and then you press the C O button. Remember, the reason why you're pressing second function or shift is because you're trying to access the other functions apart from the one imprinted on the buttons there. So which means that it's either you are going to be trying to seek for it for the functions which are written what in yellow or maroon. That's basically how you're able to access those functions. So that's basically how you clear your memory. Second rule, always put calculator to 4 decimal places unless otherwise stated. Although final answer usually expected in 2 decimal places. The reason why we say put your calculator for this at least 4 decimal places, mainly because so that when you're going to be getting your answer, you are not going to be rounding off. Because let's say, for example, you push your calculator in 2 decimal places, then you get a figure of 0.23, right? The actual amount can be 0.225. But if you're trying to get the exact amount, if the calculator rounds out to 0.23 and you use 0.23, you're going to end up missing out on some figures there as well. So which means when you're dealing with your in-between calculations there, try to put your calculator into what? At least 4 decimal places so that you're able to get a more exact answer on your calculation as well. So which means, going back to our example, it means, going back to our example, looking at our example, this is the present value. This is the interest. And this is the number of periods. So when you're given such a question, it will mean that when you're using your financial calculator, first enter the data that is given, then you ask the calculator to give you what is being asked for. So what is given? You're given that 100, you press PV because 100 is the present value. What else are you given? You're also given 12 is your interest per year. Do you see that when you're entering the interest rate, you don't put it as a decimal in your calculator, you put it as a full percentage or a full value. So 12%, you put it as 12. And you also indicate 1 is your number of periods because that's the number of periods that you have, which is the number of years in this case. So therefore, you're going to be looking for the present value. So if you do the calculation then, are you able to get the future value in this case? Are you able to determine the future value? Are we on the same page? Anyone lost? Any questions? And remember, for those who are using the HP calculator, after you enter the given information, you just straight away press FP. For those who are using the Sharp calculator, after you enter the information there, you now go and say comp, then you say comp FV because you're asking your calculator to compute the future value. So with the Sharp calculator, you're going to need first to give it a command. But with the HP calculator, you straight away tell it exactly what you need. Do you see that on your answers that you're going to get, it's giving you a positive amount, also a negative amount. That negative amount that you're getting on your calculator, you always treat it as a positive amount, unless you're calculating the net present value. So unless you're calculating net present value, the sign of your answer doesn't matter. You always treat it as what? As a positive amount, unless it asks you to calculate specifically net present value. That's when your sign of the answer is important.
Can you please demonstrate using a HP calculator, because I'm getting a different amount? It could be that I'm not sure my settings are incorrect.
All right. The other issue that you need to make sure that you deal with the HP calculator, the other issue that you need to make sure that you deal with the HP calculator is that always you make sure that your calculator is in one payment per year. So always make sure that your calculator is in one payment per year. To ensure that your calculator is one payment per year, you're going to press 1, then you press shift. Then after you press shift, remember the reason why you're pressing shift is because you're looking for the function which is in yellow or maroon, isn't it? And you see that button which says P/YR. That button is where exactly where PMT is the other function below PMT. So that when you clear your memory, it should always indicate 1/PYR, not 12. If you do the calculation again, you should be able to get the answer correctly. Can you try it and let's see if you get it right?
Thank you. Now it's correct. Yeah, I was supposed to do the one shift PYR.
Yes. So always make sure that your HP calculator is in one payment per year. This issue usually always arises with the HP calculator, not the Sharp calculator. It will never happen. But with the HP calculator, yes, always make sure that, because you can use it in four payments per year, but it gets confusing for so many students. So because of that, I would rather keep it in one payment per year. Then when it comes to adjusting for the number of periods there, you do it yourself manually. So our future value in this case is 112. Then moving on to the next example that they give us there. Moving on to the next example. Remember here we're looking at for a period of 1 year. What if the investment is for a period of 10 years? The same 100 rand, but it's now being invested for 10 years at 12% interest. Now we're trying to find out exactly, so how much is the future value? So what do we see? We're going to say 100 is our present value. 12 is the interest per year. 10 is the number of periods. And then you need to calculate the future value. And how much would you get as the future value in that case? How much would you get?
310.58.
So you get a figure of 310.58. Right? Now, looking at this value, what is the general conclusion? Do you see that the more the number of periods you're doing the calculation going into the future, the higher your future value is? Because if you do for only 1 year, the future value is 112. And if it's going to be for 10 years, the future value is going to be 310. So the more you're going into the future, the higher the future value. So the more the number of periods, the higher the future value. So this is basically what they're trying to show you in this example. So this is basically what they're trying to show you on this figure here. So this is what they're trying to show you on this figure, because they're saying the more you're going into the future, the higher the future value as well. Now, remember here, we were earning an interest of 12% per year, right? Let's look at another example. So let's look at another example where we are going to be earning an interest of 6%. So 100 is your present value. 6% is your interest. Your N is equals to 10. How much would you get as the future value? Remember here the interest was 4%, but the interest rate is now what? 6%. So if the interest rate is 6%, how much would you get as your future value?
I think I get 179.08.
So your future value would be 179.08, isn't it? So what does that mean? Do you see that the higher your interest rate, so the higher your interest rate, the higher the future value. The lower the interest rate, the lower the future value. So which means your future value is dependent on how many periods are you going into the future and how much interest are you going to be earning as well. So this is basically what figure 2.1 is trying to demonstrate there. Figure 2.1 is just trying to demonstrate that the higher your interest rate, the higher your future value. And at the same time, the lower the interest, the lower the future value as well. But the higher the interest, the higher the future value. Are we on the same page there? All right. So that's basically what it's trying to demonstrate, or what is being demonstrated using this graph as well. Now, it's not all the time that you are expected to find the future value. You can also be asked, you can also be given the information and be asked to find the present value as well. And this is what they're giving us on example 2.3. Can you quickly read through example 2.3 and we go through together?
I think I have a problem with the speaker. I can't hear you.
Sorry. So remember, originally we're given that the future value is given as the present value in brackets 1 plus r to the power of t, right? So if you're given this information, if you solve for present value, you're going to divide this side by 1 plus r to the power of t, and then you divide this side by 1 plus r to the power of t, so that this numerator is cancelled by the denominator here. So which means the present value can also be given as the future value divided by 1 plus r to the power of t. But now if you take the denominator to the numerator if it's going to be carrying an opposing sign. So if it's positive here, if the power is positive here, and you take the denominator of the numerator, if the power is positive, it's going to carry what? A negative sign. So which means if they give you using this presentation, or they give you using that presentation as well, it still gives you the same answer. But remember what we said, we are not going to be worried or more concerned with what? With using the formulas. We're going to be more concerned with exactly how do you use your financial calculator. So to get your answer, remember the next example that they gave us here. They gave us to say, your future value is 310.58, your number of periods is 10 years, and your interest is 12%, and then they ask us to find the present value. So to get the present value, I'm going to say, what are we given? We are given that the 310.58 is the future value. We are also given that 10 is the number of periods, which is number of years. We are also given that 12 is the interest per year. So given this information, they're asking us to find the present value. So if you do the calculation, how much do you get as the present value then?
Minus 100.
Remember what we said, the sign of your answer doesn't matter. If it comes out as negative, you always treat it as a positive answer. So the sign of your answer, whatever, whether the answer is going to be coming out as negative or positive, it doesn't matter. The only time the sign of your answer matters is when you're calculating the net present value. The reason why I'm saying it doesn't matter is mainly because the sign of the answer is basically confirming movements of cash flows. Because we are saying, the reason why that amount is coming out as negative is because we are saying, if you invest 100,000 today, when you're investing money, it's a cash outflow. If you invest 100,000 today, for 10 years, earning 12% interest, you get back 310.58, which is a positive amount, because you're getting back that money that you've invested. So it's just confirming movements in cash flows. So the sign of your answer, you always treat it as what? As a positive amount. The only time the sign of your answer matters when it comes to time value of money principles is when you're dealing with what? Calculation of the net present value. That's when the sign of your answer matters. If it's not that, you always treat the amount as a what? As a positive value. Are we on the same page? Looking at example 2.4, if you look at example 2.4, they give us that information. They look at calculating the number of periods given that. Can you quickly read through the example? So looking at this example, they tell us that an investment of 100 Rand will grow to 310.58, right? Earning an interest of what? 12%. So now they say, how many periods are necessary for 100 Rand to become 310.58? So look at the movement in cash flows. Now, whenever you are given the present value and future value together, one of them has to be negative. So when you're entering the information, one of them has to be negative because you're confirming the movements in cash flows, because you cannot invest money and now have an outflow again in the future. It's either you invest money today and you get back your money, or it's either you borrow money today and you pay back that money. That's basically how it works in investments, isn't it? So which basically means if you are given that you're investing money today and getting that money back after whatever period of time, earning 12% interest, then now you have to find out exactly how many periods are you going to be, it's going to take for this money to grow to that amount. It basically means you are given the present value and the future value. So whenever they give you present value with future value, or present value to future value and PMT, always make present value the negative amount. So which means in this case, you're going to say 100 plus or minus, then you indicate that is your present value because You're indicating that the present value is the amount that you're putting in as what? Negative amount. Then you say 310.58. 310.58 is your future value. 12 is your interest per year. Then you calculate your N. And let's see how much you get as your number of periods. And how much would you get there?
10.
10. So your number of periods is going to be equal to 10. Remember what I told you. When you do the calculations on under normal circumstances, the sign of your final answer doesn't matter. Whether it's positive or negative, you treat it as a positive amount. But when you are now looking at the relationship between the cash flows, whenever you're given the present value, PMT, and future value, check the movement in cash flows. If you invest money and you get back that money later on in the future, it basically means that on day 0, you're spending money, it's a cash outflow. On whatever period of time in the future, you're going to get that money back and with the interest, so which means that it's your positive cash flow. So when you're entering the information, the sign of your amount is important. But whenever you are getting an outcome from a calculation, the sign of your amount doesn't matter unless you are specifically calculating the net present value. Are we on the same page? Any questions? Moving on. The next example that we're going to be looking at is calculating the interest rate. Now, when calculating the interest rate, don't worry about that formula that is confusing where they give you this formula. Don't worry about it. You will never be asked to do this. Whenever you're looking at calculation of interest rate, or whatever amount it is, always use your financial calculator. Don't worry about using the formulas. They will never ask you to do that. So looking at example 2.5, they tell you that you are investing 100 Rand today and getting 310.58 after 10 years. Then they ask you exactly what is the interest rate. So what does that mean? You are given that 100 Rand, which is the money that you're investing today, is your present value. 310.58 is your future value. You're also given that 10 is the number of periods. Then they ask you to calculate the interest rate. How much would you get as your interest rate?
12.
12. So it might seem a bit of a drag now, but I promise you, you need to know these basics for you to be able to now understand what is happening from chapter 9 onwards. That's why you see that although we're not going to spend too much time and so it is wasted a lot of time, we would rather concentrate more on the practice questions so that you're able to now refresh your mind and refresh things that you already know. You're assumed to be already knowing as well. On the next section, we look at single amount, multiple periods, and non-annual compounding. So we look at single amounts, multiple periods, and non-annual compounding. So to understand this better, they give us example 2.6. Can you quickly read through example 2.6 and we go through it together? So here, they tell us that you deposit 100 Rand into an account, which offers 12% interest compounded monthly. And then they say, what is the value of the investment after 1 year? but the interest is being compounded what? Monthly. So what do we know? If you're compounding more than once a year, remember initially our formula was your future value is equal to present value in brackets 1 plus R to the power of T. But if you're going to be compounding more than once a year, it basically means that this formula is going to change. The formula changes to your future value is equal to your present value in brackets 1 plus R over M to the power of TM, where R is your interest rate, your nominal annual interest rate, M is the compounding frequency per year, and T is the number of years at which you're going toward as well. So your formula now becomes this. So which means, although we're not going to look at it using the using the formula to get the answer, if you're going to be finding the answer using the formula, it would mean your present value is given as 100 in brackets 1 plus. Your interest of 12% is being compounded monthly. So if you're compounding monthly, it means you're compounding 12 times a year. If you're compounding semi-annually, it means you're compounding twice a year. And if you're compounding quarterly, it means you're compounding 4 times a year. And if you're compounding weekly, you're assumed to be compounding what? 52 times a year. So your M becomes 52 times if you're compounding annually. And if you're compounding daily, you're assumed that you're going to be compounding what? 365 times a year. Compounding basically means interest is being added to the principal amount and being reinvested. So you're basically saying, over the investment horizon, how often is interest being added to the principal amount and being reinvested together, and the two being reinvested together? So if you're compounding daily, it means every day, at the end of each day, interest end is added to the principal amount and it's going to be reinvested together. They're going to be reinvested together. So which means in this case, it would mean your interest of 12% is 0.12. And if you're compounding as monthly, it means you're going to be divided. Your M is 12 because you're going to divide what you are going to be compounding monthly. So which means 12 times a year. And we have 1 year that you're moving forward and you're compounding 12 times a year. So this is basically how your formula would simplify to. But remember what we said, we are not going to worry about using the formula. We are going to be more concerned with using what? Your financial calculator. So when you're using your financial calculator, you're going to say your present value is given as 100. Your interest is going to be given as I over M. If you say I or you use R, it's basically the same thing. So your interest is given as I over M, where I is your nominal rate of interest and M is the compounding frequency per year. So which means in this case, your interest is going to be, your annual interest is 12% and you're compounding 12 times a year. So this becomes your interest. Your N is given as T multiplied by M. So T times M, where T is the number of years and M is the compounding frequency per year. So which means in this case, you're moving forward for 1 year, your T is 1 year, and you're compounding 12 times a year. So given this information, we can now be able to calculate the future value. So how much would you get as the future value? You're going to say 100, you press PV, 12 divided by 12, get the answer. You don't write it down separately. Just say 12 divided by 12 on your calculator, whatever is appearing on your screen, you press interest per year button. Then you say 1 times 12, whatever is appearing on your screen, you press N, then you look for the future value. And how much would you get as the future value in this case? You should be able to get a figure of, how much do you get?
112.68.
112.68. Do you see that initially it was 112 rate? Now it's 112.68. Initially we're compounding once a year and we got a future value of 112. Now we're compounding monthly, we're getting a future value of 112.68. Please take note of that. Can we move on? Any questions? And if it's going to be for 10 years, our present value is 100. Our interest is going to be 12 divided by 12. Our N is going to be 10 years. So it is 10 multiplied by 12. And then you should be able to get a future value of 330 point, 330.04 to 2 decimal places round up to 04. And initially it was 310.68, isn't it? Now it's 330.04. So what does that mean? The conclusion here would be the higher the compounding frequency, the higher the future value. So the higher the compounding frequency, the higher the future value. So please take note of that relationship. The more you're compounding in a year, the higher the future value. So which also brings us to another issue as well. If you're going to be taking out a loan from a financial institution, you also need to be interested to find out exactly, so how often is the interest being compounded? Is the interest being compounded daily, weekly, monthly? Because the more the number of times the interest is being compounded, the more the future value that you have to pay back.
I'm sorry. I'm sorry. I think I'm lost on the one with the 10 the n10 multiplied by 12. I get a different value. I don't know, where did I go wrong?
Did you clear your memory?
Yes.
And then you said 100 is your present value.
Yes, 100 is my
Then
PV.
12 divided by 12 is your interest.
Yes.
Then 10 multiplied by 12 is your number of periods.
And then I'm using a sharp. I say comp FV. Oh,
yes.
Okay. Now maybe I made somewhere a mistake because it gives me.
And remember, unless the data entered is too relevant, always clear your memory. So unless the data entered is too relevant, always clear your memory. Any other questions? Let's move on to the next section. On the next section, they look at the annual effective rate. Remember, so we saw that the more the number of times you're compounding, the higher the future value is. So the more the number of compounding, the more the number of times you're compounding, the more interest you're bound to pay. Because if you start off with 100 Rand, if it was for only 1 year, your future value, which is the amount of money that you have to pay back, is 112.68. So which means you are basically paying 12.68 as interest for 1 year. But previously, when you're compounding once a year, you're only paying 12 Rand. And the same applies when you're for 10 years. You were only paying, remember initially the future value was 310.68. So you're only paying for 10 years, you're paying 10.68 as interest. Because remember, your interest is the difference between your future value and your present value. But now, how much interest are you paying? 30 Rand, 4 cents. So the more the number of times you're compounding, the more interest you're paying, because the higher the future value. So when you want to find out exactly, so what is the effective rate of interest I'm paying, depending on exactly how many times I'm compounding, it would mean your effective annual rate of interest is given as 1 plus your nominal interest divided by the number of times you're compounding to the power of the number of times you're compounding minus 1. So this will give you the effective annual rate of interest. So which means if you're compounding once a year, So if you're compounding once a year, it means your M is equals to 1 because you're compounding once a year. If you're compounding once a year, in this case, your effective annual rate of interest would be equal to 1 plus, remember in all these cases, your interest rate is 12%, so 0.12 divided by 1 to the power of 1 minus 1. So you see that your effective annual rate of interest remains at 12% if you're compounding once a year. But now what happens if you're compounding 12 times a year? If you're compounding 12 times a year, your effective annual rate of interest is equal to 1 plus 0.12 divided by 12, because your M is equal to 12. So 0.12 divided by 12 to the power of 12 minus 1. So given this, how much would you get as your effective annual rate of interest? So given this scenario, how much would you get as your effective annual rate of interest? So how much would be your effective annual rate of interest?
$12.68.
So it will be 12.68%. Because remember, whatever amount you're going to get there, you're going to multiply that by 100 to make it a percentage. So it will give you 12.68%, which is the 12.68. But as a percentage of 100 range, it's going to be 12.68%. So what does that mean? The more the number of times you're compounding per year, the higher the effective annual rate of interest you're going to be paying. So the more the number of times you're compounding per year, the higher the effective annual rate of interest you're going to be paying. Are we on the same page so far? Any questions? Anyone lost?
So annual effective rate cannot be computed on the financial calculator. That's why it's only based on a formula and the normal calculator.
It is, but don't worry much about it, but it is, but I don't want to confuse you because remember, you now need to learn it using the sharp calculator or the HP calculator. For now, just know how to use the how to do the calculations using your formulas there. Now, we have seen so far that you can compound annually, you can compound semi-annually, which is twice a year. You can compound quarterly, which is 4 times a year. You can compound monthly, which is 12 times a year. You can compound weekly, which is 52 times a year. You can compound daily, which is 365 times a year. But you can also compound every microsecond as well. So which means every microsecond, the interest will be added onto the principal amount. So this is where we look at continuous compounding. So this is where we'll be looking at what? Continuous compounding. So with continuous compounding, you now need to know exactly how do you determine the present value or the future value as well, using continuous compounding. So with continuous compounding, the future value is given as the present value times the exponent of CT, where C is the continuous compound rate, and T is the number of years. So so which means with continuous compounding, the future value is given as the present value multiplied by the exponent of the continuous compound rate multiplied by the number of years. And the continuous compound rate, remember we said whenever you're putting something in a formula, it has to be in decimal. So it has to be in decimal format. So given this information, it would mean, for example, if you are going to be given an amount of 10,000, which is invested at a continuous compound rate of 6% for 10 years, so which means you're given that your present value is 10,000. Your continuously compounded rate is 6%, and you're also given that the number of years is equal to 10 years. So given this information, if they're going to ask you to find the future value, it would mean your future value is going to be your present value of 10,000 multiplied by the exponent of the continuously compounded rate as a decimal of 0.06 multiplied by the number of years in this case, which is equal to 10. And this will give you the future value. So to calculate this using your financial calculator, if you're using the Sharp calculator or other scientific calculators, you're going to punch 10,000. You look for the value which is written E with an X on top. So that's basically the exponent of a value. So whenever you want to find the exponent of a value, you press this button E with an X on top. Usually in some like Casio, it's straightforward, it's straight into be an E with a function like this. So that's basically how you find the exponent of a value. But with other calculators, you have to say second function, then you press E with an X because it's on the second function. So that's the second function on your calculator thing as well. Then after that, whenever you're putting something to the power of a multiple or the power of a decimal, you have to open brackets. Then you say 0.06 times 10, then you close your brackets, then you say equals to. If you're using the HP calculator, you have to work it backwards. So you start with the power, then working it backwards. So what are you going to do? You're going to say 0.06 times 10, you get your answer. Then you say shift, then you look for E with an X on top. Then you have now looked for the exponent of this value. Then immediately after that, you multiply this by 10,000, and this will give you the future value. And how much would you get as the future value in this case? So how much will be the future value?
Please repeat how you can do it.
With which calculator?
HP.
So with the HP calculator, you need to work it backwards. So you start with the power, working backwards. So you're going to say 0.06 multiplied by 10 equals to, because you're going to get your answer there, right? Then after that, you press shift, then you press E with an X on top. So that you're saying, because you're basically saying, what is the exponent of what I've calculated so far? So it's 0.06 times 10, shift, you press E of X, you get your answer. Then after you get your answer, then you multiply it by what? By 10,000. How much do you get?
I'm still trying to find an E.
With which calculator are you using?
It's a Sharp. It's a HP.
Do you see where the button
yeah,
one
it's on
is?
one.
On
Okay,
yes.
one.
Yes.
No, I wanted to help Sibusiso.
Oh, okay.
I think E with an X, it's on the plus or minus with a sharp EL738.
Oh, yeah. How much are we getting as the future value?
With the sharp calculator, sorry, are we putting the bracket there with the 0.06 times 10?
Yes. Because whenever if you don't put brackets, the calculator assumes that only 0.06 is the one that is being put to the exponent of. But remember, it's this whole thing. So to take into account this whole power, you open brackets, then you say 0.06 times 10, you close brackets there. So that the calculator knows that this has to be solved first before you look for its exponent.
Okay, thanks.
How much do you get?
I get 18 to 1.19.
188, which is 19. Eh?
Yeah.
All right. Are we on the same page? Any questions? Anyone lost?
I'm lost. My answer gives me an error one.
Which calculator are you using?
Sharp.
You said 10,000 and then?
I said 10,000. I press PV. And then
you don't have to press PV. You punch it directly as this, as is like this.
Okay.
So with the sharp calculator, you say 10,000. Second function, E of X, open brackets, 0.06 times 10, close brackets, equals to.
Then with an HP, can you take us through the step? Because I'm also getting different amount from the 18,000 with an HP.
With the HP calculator, remember we said you start with the power going backwards, isn't it? So you're going to start off by saying 0.06 times 10. You get your answer. You don't round off that answer. You don't write it separately somewhere. Immediately after that answer that is showing on your screen, immediately after that you say shift, then you press E of X. Then immediately after you get the answer there, you multiply that answer by what? By 10,000. Are we coming right?
No, we coming all right.
Okay. Any questions? Anyone lost?
I think I'm still lost because my answer gives me 106.18.3. This amount is.
Which calculator are you using?
I'm using Sharp.
You said 10,000, right?
Yes.
Then shift E of X.
Okay.
Open brackets. 0.06 times 10, close brackets, equals to.
Oh, okay. Maybe I made a mistake of not opening the brackets. Thank you.
If you don't open and close brackets, you know what your calculator assumes? It assumes that the exponent that you're looking for is only of 0.06. But the exponent you are looking for is actually of the multiple of 0.06 times 10. That's why we're putting brackets so that you remember, the calculator knows that, remember, use rules of BODMAS, brackets off. So whatever is in the bracket has to be solved first before you do anything else. So since these ones are going to be multiplying each other, that's why we're putting them in brackets, because they have to be solved first before we look for the exponent. Are we together? Any questions? Anyone lost?
Sorted. Thank you.
All right. Now, you can also be given a situation where, remember, we are given the present value, the continuously compounded rate, and the number of years there as well. They can, so this formula can also be simplified into, you can also be asked to find the present value as well. So what do we know? The present value, so the future value is given as the present value times the exponent of continuously compounded rate times t. Now, if you divide this side by e of ct to cancel that, we're also going to divide this side by e times ct, because remember, whatever you do on the right-hand side, you also need to do it on the left-hand side, so that this cancels that. So which means the present value can also be simplified into the future value divided by the exponent of the continuously compounded rate times t. But what do we also know? We also know that if you take the denominator and put it to the numerator there, if it's carrying a positive sign, it's going to carry a negative sign. So which means the present value can also be given as the future value times the exponent of what? Minus continuous compounded rate times t. So let's look at another assumed example. The assumed example would be, let's say you are given that your future value is 18,221.19. You're also given that the continuously compounded rate is equal to 6%. You are also given that the number of periods is equal to 10, or the number of years is equal to 10. Then they ask you to find the present value. So to find the present value, we're going to say the present value is equal to the future value of 18,221.19 times the exponent of minus 0.06 multiplied by t, which is 10. So given this information, how much would you get as the present value? Remember, on your calculator, to make a value negative, you don't press the minus button, you press the button with the plus and minus on the same button. So that you need to make a value negative, you always press the plus minus button on your calculator. So please make sure that you take note of that. How much do you get?
I think I get 10,000.
Yes, you must be able to get a figure of 10,000. Are we together? Any questions? Any questions? Anyone lost?
Sorry, Rhino. So the PV, are we putting it as a negative or are we just putting it as a positive?
When you are putting future value and present value in a in the formula, you always treat them as positive amounts. Remember, you're putting this in a formula. So whenever you're putting values in a formula, you always treat them as positive, as what? As positive amounts. But what you need to take note of here is that the CT is being made negative. Any questions? Anyone lost?
So Rhino, basically what you're saying, the CT always comes with a negative amount.
If you are looking for present value. Why is it negative? Because when you solve mathematically for present value, this is on the denominator. So to make it positive, so to put it on the numerator, you have to what? If it's positive here, you have to make it negative, the power. So it's based on the mathematical manipulation of the what? Of the formula. Any other questions? All right, can you take a few minutes break until 12:35? Then at 12:35, we're going to be looking at annuities. So can you take a few minutes break until 12:35? Then at 12:35, we are going to look at annuities. All right, can we continue? So on the next section, we are going to be looking at series of investments, ordinary annuity, and multiple investments in multiple periods as well. But I'm going to be mashing it together, where I'm going to be looking at ordinary annuity and annuity due as well to find the future value and the present value as well. So we're going to be now starting to bring in the concept of our present value. Remember, we've seen it before. We're looking for present value, which is the value of the investment today, right? So we are going to be looking at annuities, and with annuities, we're going to find out exactly, so how do you find the present value or the future value of a particular annuity as well? So I'm going to steer away from the example that I give in the textbook. I'll give you my own example because there's a point of relationship that I need you to make sure that you take note of when it comes to annuities as well. So let's say, for example, remember, if you look at the definition of an annuity is a series of equal periodic cash flows. So by definition, an annuity is a series of equal periodic cash flows. Let's say, for example, you have periodic cash flows over a 3-year period. So over a 3-year period, year 1, 2, 3, you are expecting a periodic cash flow of, let's say, 10,000, 10,000, and 10,000. If the annuities are happening at the end of each period, so if the annuity, remember we said an annuity by definition is a series of equal periodic cash flows. So if these periodic cash flows are happening at the end of each period, where the cash flow for year 1 is happening at the end of year 1, for year 2 is happening at the end of year 2, and for year 3 is happening at the end of year 3, we call this, so we refer to this as an ordinary annuity. So we refer to this as an ordinary annuity. Now, let's look at another example of series of cash flows over a period of 1, 2, 3 years. And these the cash flow for year 1 is happening at the beginning of year 1. For year 2 is happening at the beginning of year 2. And for year 3 is happening at the beginning of year 3. If the annuity payments are happening at the end of each period, we refer to this as annuity due. So ordinary annuity, under normal circumstances, if they don't say anything, you assume it's an ordinary annuity. But if they say the payments are being made in advance, or the payments are being made at the beginning of each period, then it basically means that we are dealing with an annuity due. Do you see the difference in timing between the ordinary annuity and annuity due? There are other 2 types of annuities we're going to look at after this, but I'll discuss them with you just now after we look at these 2 types of annuity. So the other types of annuities we're going to be looking at is perpetuity and deferred annuities as well. So we're going to look at the perpetuity and deferred annuity, but we'll look at them after we look at these 2. So with ordinary annuity, you can either be asked to find the present value of the ordinary annuity. And if it's the present value of an ordinary annuity, it means you're discounting these cash flows back to year 0. Or you can be asked to find the future value of this ordinary annuity. And if it's the future value of the ordinary annuity, it means you're compounding these cash flows going into the future. So let's first look at a scenario where we are looking at finding the present value of ordinary annuity. We are assuming that in all these cases, our interest rate is 10%. So in all these examples, we're assuming that the interest rate is 10%. So if that is the case, it would mean For ordinary annuity, there's no complications when it comes to the calculations. What are you going to do? We know that the payments are 10,000 every period. So the annuity, when you're entering an annuity on your calculator, that's the PMT button on your calculator. So the PMT button on your calculator basically acknowledges what? Annuities. So what do we know? We know that 10,000 is your PMT because that's the annuity, right? What else are we given? We also know that 10 is the interest. How many periods are we dealing with? We're dealing with 1, 2, 3 periods. So we also know that 3 is your number of periods. So given this information, can you calculate the present value of this annuity and how much do you get? So can you calculate the present value of this annuity and let's see how much you get.
24,868.52.
So you get 24,868.52. Are we on the same page? Any questions? Anyone lost? Now, apart from finding the present value of the ordinary annuity, you can also be asked to find the future value of an ordinary annuity as well. So to find the future value of ordinary annuity, you're going to say, what am I given? 10,000 is my PMT, 10 is my interest, 3 is my number of periods. But now you're looking for the future value. And how much would you get as the future value of this ordinary annuity?
I think the answer is 33,000 minus 33,100.
Yes, it's 33,100. Remember we said, unless you're calculating net present value, always treat the value of whatever you're getting as a positive amount because it's just confirming movements in cash flows. Are we on the same page? So it's 33,100. Are we on the same page so far on what we have done? Any questions? Anyone lost? So can you move on to calculating the, dealing with the annuity due? Now, with an annuity due, you are telling your calculator that the payments are being made in advance. So it's the same annuity payments, but these payments are being made in advance. So if you're using the HP calculator, to put your calculator into annuity due, you are going to say shift B, then you press BEG /end. And on your bottom of your screen, it will show you BEG. The moment it shows you BEG at the bottom of your screen, after you do this, it means it's acknowledging that the payments are being made at the beginning of the period. And if you're using the sharp calculator, you're going to press second function, BGN /end. And on the top of your screen, it will show you BGN. So it means that the calculator is acknowledging that the payments are being made at the beginning of each period. Are we on the same page so far? Is it showing BEG at the bottom of your screen? And is it showing BGN at the top of your screen if you're using the sharp calculator. Are we together there? Any questions? Anyone lost? Now, after you do that, everything else is as normal, like what we've done here. What are you going to do? If you're looking for the present value of annuity due, so if you're looking for the present value of the annuity due, you're going to say 10,000, because remember, you're now discounting these cash flows back to present value if you're using what? Annuity due. So 10,000 is your PMT. 10 is your interest. 3 is your number of periods. Then you look for present value. And how much would you get as the present value of an annuity due?
27355.37.
27355.37. Okay. 27355.27. 0.37. Then you can also be asked to find the future value of an annuity due. So you're given 10,000 is your PMT, 10 is your interest, 3 is your number of periods. How much would you get as the future value of an annuity due?
$3,310.
The future value. Remember, your PMT is 10,000. Your interest is 10%. Your number of periods is 3.
I get 36,410.
Yes, you should be able to get a pick of 36,410. Are we on the same page? Any questions? Anyone lost? Now, there is this vital relationship we need to understand. Do you see that the present value of an ordinary annuity is less than the present value of an annuity due? And the future value of an ordinary annuity is less than the future value of an annuity due. The reason why it's like that, let's look at a simple example. If someone says they're owing you money, and then they give you two options, they either pay you back 1,000 rand that they're owing you today, or they pay you back the same 1,000 rand after 1 year. What would you prefer? Getting the 1,000 rand today or getting the 1,000 rand after 1 year?
Getting the 1,000 rand now.
Yes, so you would prefer to get the 1,000 rand now, because if this 1,000 rand after 1 year, it would be the 1,000 rand plus interest. So it's gonna be worth to you more if you get it today, isn't it? Are we on the same page? And also, the 1,000 rand that you're getting after 1 year is actually worth less to you today than getting the same 1,000 rand after 1 year. So you'd rather get your money today. So do you see that the timing of your cash flows is very, very important? Because if you are discounting these cash flows back to present value, this 10,000 range is going to be worth less if you discount it. This one is going to be worth a lot less, and this one is also going to be worth much more less. But if you look at the timing of the cash flows here, this one, the 10,000 rate that you're getting after 1 year is the same 10,000 rate that you're getting today. So you'd rather get it today because it's worth more for you today as well. And the same applies when you're looking at the future value as well. The value of the 10,000 today is going to be worth more to you because of the effect of what? Of interest, because you will be having an extra 1 year period to earn interest on that money. So what does that mean? Unless under normal circumstances, the present value of an ordinary annuity is always going to be less than the present value of an annuity due. And also, the future value of an ordinary annuity is always going to be less than the future value of an annuity due, given that everything else is the same. So given that everything else is the same, the present value of an ordinary annuity is always going to be less than the present value of an annuity due. Also, given that everything else is the same, the future value of an ordinary annuity is always going to be less than the future value of an annuity due. Are we on the same page? Any questions? Anyone lost? Now, let's look at another scenario. Now, we are going to look at a case where we're now going to look at a case where we are going to be looking at perpetuities and deferred annuities. So we're going to also look at perpetuities and deferred annuities. Now, the other type of annuity we're going to be looking at is the perpetuity. A typical example of a perpetuity is where we are saying you are receiving the 10,000 rand, but your receipts of the 10,000 rand is going to be until what? Forever. So whenever they say the cash flows are forever, infinite cash flows, or endless stream of cash flows. So if they say an infinite stream of cash flows, an endless stream of cash flows, or they're saying that the cash flows are going to be received or paid forever, then you know you're dealing with what? A perpetuity. And with a perpetuity, they will only ask you to find the present value of a perpetuity. So they will only ask you to find the present value of a perpetuity. And the present value of a perpetuity is given as the annuity divided by the interest. And in this case, the interest has to be put in as a decimal. So the interest has to be entered as a decimal. So which means with the perpetuity, we are discounting all this endless stream of cash flows back to present value, but you don't know these cash flows are going to be assumed to be running until forever. So remember we said the assumption here was your interest is 10%. So which means in this case, the present value of a perpetuity is given as the annuity of 10,000 divided by your interest as a decimal. If it's 10% divided by 100, gives you 0.1. So how much is the present value of this perpetuity? How much do you get?
100,000.
100,000. So in simple terms, we are also saying if you invest 100,000 today, earning an interest of 10%, you are able to withdraw 10,000 at the end of each year forever. So if you invest 100,000 today, earning a 10% interest, you are able to earn a return of 10,000 forever. The other type of annuity is what we refer to as the deferred annuity. So the other type of annuity is what we refer to as a deferred annuity. A typical example of a deferred annuity, let's say, for example, we are given a timeline over a period of 1, 2, 3, 4, 5, and 6 years. And then they say the annuity payment of 10,000 are going to be, there is no payment of 10,000 for the first 3 years, but after that, that's when there's going to be an annuity payment of 10,000 at the end of each year after that. So there's no payments for the first 3 years, but then after that, the annuity payments start kicking in for 3 years. So this is typically what we refer to as a deferred annuity, that the annuity payments are going to be there, but they're only going to be paid after a given period of time. So now we need to find out exactly how do we determine the present value of this deferred annuity. So which means we are trying to discount these annuity payments back to present value, and this annuity payment back to present value, and this annuity payment back to present value as well. And there are no annuity payments on year 0, 1, year 1, 2, and 3. Because you defer making the payments, but then after that, they start kicking in. So how you find the present value of a deferred annuity? You are going to say, you need to acknowledge the cash flows for each period. So we know for year 0, there is no stated cash flow. For year 1, there is no stated cash flow. For year 2, there is no stated cash flow. For year 3, there is no stated cash flow. And let's assume that the interest rate in this case is still the same, 10%. So there's no cash flow stated for years period 0, 1, 2, 3, 4, period 1, 2, 3, but year 4, 5, and 6, the cash flows are given. So if ever you're asked to find the present value of a deferred annuity, then you can use the net present value method to calculate the present value of this deferred annuity. How you can do that is that you're going to say, with your sharp calculator, you need to first enter the cash flows starting from period 0. So period 0, there's no cash flow entered. So you're going to say 0, you press enter. Then you need to enter the cash flow for year 1. Then you say 0, you press enter. For year 2, 0, you press enter. For year 3, 0, you press enter. For year 4, the annuity payment is 10,000. So you're going to say 10,000, you press enter. For year 5, it's 10,000, and then you press enter. And for year 6, it's 10,000, and then you press enter. After that, you're going to say second function. Then you press CFI button on your calculator. Then remember, the interest is going to ask you for the rate per year, and your rate per year is 10. Then you press enter, you scroll down, and then you ask the calculator to compute for you. If you're using the HP calculator, you're going to say 0, you press the CFJ button. The CFJ button is the one that is next to the percentage button. So the button next to the percentage button is basically the CFJ button. Then after that, for year 1, 0, CFJ. For year 2, 0, CFJ. For year 3, 0, CFJ. And for year 4, 10,000, CFJ. For year 5, 10,000, CFJ. For year 6, 10,000, CFJ. Then after that, you're going to upload the interest per year. So 10, you press the interest per year button, then shift, then you look for, then you press the NPV button on your calculator. So which means, in this case, the net present value is also the present value of your deferred annuity. So the net present value that you're going to calculate there is also the present value of your deferred annuity. And how much is the present value of this deferred annuity? Please take note. Very, very important thing. After you do your calculations in beginning mode, always put back your calculator into what? Into end mode. And how do you put your calculator back into end mode? If you're using the HP calculator, the same steps that you took before are the same steps that you're going to take again. But now this time, it should not show you BEG at the bottom of the screen. So if you say second function, BEG/end again, the BEG disappears. Because under normal circumstances, your calculations are always assumed to be made under non-ordinary annuity or under non-ordinary conditions. So because of that, if not stated, you assume you're in end mode. So you must always make sure that your calculator is not in end mode under normal circumstances, unless otherwise stated. And if you're using the sharp calculator, the same thing or the same steps, second function, BGN/end. And you see that the BGN at the top of your screen, it disappears. Then you know that you're now in what? In end mode. So under normal circumstances, do your calculations in end mode, unless otherwise stated. So given this information, how much do you get as the net present value of this deferred annuity?
$18,684.09.
So you get a figure of 18,684.09. Are we getting the same amounts? Yes. Any questions? Anyone lost? Any questions? Anyone lost? So far, from where we left off in the textbook, we have looked at these sections where we looked at future value of an ordinary annuity. We have also looked at annuity due, future value of an annuity due. We have already covered that. Then we have looked at future value when timing the cash flows in the compounding periods. Then we have looked at the present values as well. We have already looked at that when we looked at that particular example, whether it's a single amount or even under annuity dues as well. We have already looked at them. So for single amounts, we've looked at 300 exactly how to find the present value, because everything is still the same. You enter what is given, and then you ask the calculator to calculate for you what is being asked for. So ordinary annuity, the present value of the cash flows, we have already looked at it. Then annuity due, cash flows, the present value of the annuity due, we have already looked at it as well. Deferred annuity, we have already looked at it as well. So on the next section, we are now going to be looking at uneven streams of cash flows. So we're not going to be looking at the cases where we are given an uneven stream of cash flows. So on the next section, we're going to be looking at a case where we are given an uneven stream of cash flows. So when you have an uneven stream of cash flows, this is where you're dealing with cash flows which don't follow a particular pattern, right? They're not the same. They're basically random. Remember, when you talk about annuities, the cash flows are the same for a given period of time. Now, if it's an even stream of cash flows, the cash flows are basically random. So you're given a case where the cash flows are random. So which means that if you are going to be dealing with cash flows which are random, now we need to find out exactly. So how do you find out I will look at another example where we look at finding the present value of an uneven stream of cash flow. Then I'll also give you an example where we look at finding the future value of an uneven stream of cash flows as well. So I'm not going to use the example in the textbook. I'm going to use the, my own example, which is a bit more practical. So a typical example of an uneven stream of cash flows is where we say, for example, over a 4-year period, we have cash flows of 12,000, 18,000, 21,000, and 22,000. So these cash flows, they don't follow a particular pattern. And we assume that the interest rate is 8%. So they can ask us to find the present value of this uneven stream of cash flows, because it's uneven because these cash flows are random and they're not following a particular pattern. So which means in this case, they can ask us to find the present value of this uneven stream of cash flows. So they are basically discounting these cash flows back to present value. And what do we see? There is no cash flow mentioned for year 0. So we're going to we always have to acknowledge the cash flow for year 0 whenever you're dealing with what? Entering to find the net present value, which is the method that we're going to be using in this case. So which means for an even stream of cash flows, if they ask you to find the present value of an uneven stream of cash flows, if you're going to be using the HP calculator, you need to first off acknowledge the cash flow for year 0. And in this case, the cash flow for year 0 is what? 0. So you're going to say 0 CFJ. For year 1, it's 12,000 CFJ. For year 2, it's 18,000 CFJ. Then 21,000 CFJ. Then 22,000 CFJ. So you've now entered the cash flows up to period 4. Then after that, you're going to say 8. You press the interest per year button, then shift, then net present value. So this will give you the present value of an even stream of cash flow. If you're using the sharp calculator, you're going to say 0, you press enter. 12,000, you press enter. 18,000, you press enter. 21,000, you press enter. 22,000, you press enter. Then second function, CFI, 8, you press enter. You scroll down, and then you compute. So which means in this case, the net present value that you're going to calculate is also the present value of this uneven stream of cash flows. And how much do you get?
$59,384.34.
Okay. So you get a present value of 59,384.34. Are we getting the same amounts? Any questions? Anyone lost? They can potentially also ask you to find the future value of this uneven stream of cash flows, which means you're moving these cash flows going to the future. So you're moving these cash flows going to the future. Although it's not a common practice for honors modules, mainly because these time value of money principles, we're going to be using them mostly for valuations. And when you're valuing something, we say the value of a security today is the present value of expected future cash flows. So usually when valuing something, we use time value of money where you're looking for the present value. But even if it's an even stream of cash flows, you can also be asked to find its future value as well. So how you find its future value is we are now going to say, you can have a table where you have the present value, the interest rate, the number of periods, and the future value of that amount. So you're going to be treating them separately. If you're asked to find what? The future value of an even stream of cash flows. So to find the future value in this case, you're going to say, start off with the 12,000. The 12,000, the present value is 12,000. This money is going to be reinvested for 1, 2, 3 years. So it's got 1 year, 1 full year, 2 full years, and 3 years until you get to the end of the investment horizon. So your interest is 8%, but it's being invested for a period of 3 years. Then you look for its future value. The same with the 18,000. With the 18,000, if you receive the money here, you're going to be having 1, 2 full years to invest. So you're going to be earning interest, but you're investing for 2 years. The 21,000, you're going to be earning 8% interest, but you're going to be having 1 full year to invest. Then the 22,000, you're going to be earning 8% interest, but it's already in the future, so you have 0 years to invest. So we already know that this remains as 22,000. It's not going to change. But now we need to find out exactly what is the future value of this individually, of that individually, of that individually, and this individually. Then the sum of this individual future value would give you the future value of an uneven stream of cash flows. So if you do the calculations, you'll see that your future values would be so if you're compounding, if you're going to be looking for the future value of an uneven stream of cash flows, this is how you're going to be able to find the future value there. Are we together? Any questions? Anyone lost? Moving on. They also discussed perpetuities, finding the present value of a perpetuity. We have already discussed that. Then the other types of annuities we're going to be looking at, another type of annuity we're going to be looking at there is a growing perpetuity. So this is where the annuity is going to be growing at a certain rate. And the growing perpetuity basically follows the same principle as the dividend discount model, right? So with a growing perpetuity, we say when you're dealing with when you're dealing with a growing perpetuity, we say so when you're dealing with a growing perpetuity, the present value of a growing perpetuity is given as, so the present value of a growing perpetuity is given as your PMT, which is the annuity, in brackets 1 plus the growth rate, over your required rate of return, which is R minus the growth rate. So this will give you the present value of a growing perpetuity. So the present value of a growing perpetuity is given as this. So to understand this better, they give us that information. So they give us that information. So can you read through this paragraph? They say, if a company has just made payment of 10 million, and this is expected to grow at the expected inflation rate of 3% per year, and the discount rate is 8%, then the present value of the payment stream is going to be equal to. So your perpetuity is the 10 million rand. It's going to be growing at 3%, and the discount rate which you're going to be using in this case is equals to 8%. So to find the present value of this growing perpetuity, I'm going to say the present value is equals to 10 million in brackets 1 plus the growth rate as a decimal. So the growth rate and the interest rate per year always have to be added as a decimal if I'm going to put them in the formula. So the growth rate is 3%, so it's 0.03 over the required rate of return. On the question, they say the required rate of return or the discount rate is equals to 8%. So as a decimal is 0.08 minus 0.03. So given this information, how much would you get as the present value of this growing perpetuity? So you should be able to get a figure of 206 million. So you should be able to get a figure of 206 million. Then you can also be asked to find, dealing with growing annuity. So which means in this case, the annuity period, the annuities are going to be up to a certain period of time. So the annuities are going to be up to a certain period of time. So we need to find out exactly how do you find the value of the growing annuity. And they give us as an example here, if you check in the textbook, they tell us that they give us this example. Can you quickly read this paragraph and we go through together? So they say you're expecting to receive a salary of 360,000 and it's going to be growing 6% for the next 40 years. And if your required rate of return is 9%, they'll ask you to find the present value of this amount or this annuity that you're going to be receiving. Please note, I have never seen this question coming in the exam, so don't stress much if it's not given, because it's not something that has been covered when you're doing your undergrad. So it's there, but I've never seen this question, anything related to this coming in the exams or past assignments. So if ever they ask you to find the present value of this growing annuity, the present value of the growing annuity would be given as your annuity of 360,000 multiplied by 1 plus the growth rate, which they say is 6%, multiplied by, in bigger brackets, 1 minus 1 plus the growth rate of 0.06, and this is going to be over a 40-year period, divided by 1 plus the interest rate. On the question, they give us that the interest rate is 9% per year, which is the required rate of return. So it's 0.09 to the power of 40. Then all this is going to be divided by 0.09 minus 0.06. And this will give you the present value of a growing annuity. Take note of it in case it comes in the exam so that you are familiar with it or in the assignments, but I've never seen this coming in the assignments or the exam. So your answer here is going to be an amount of 8,554,551. Just take note of it, but don't dwell too much on this one. Just take note of it, but don't dwell too much on this one. Can you move on? On the next section, we are going to be looking at inflation and real rate of returns. Please take note of this because it's a concept that is going to be coming in again later on in the curriculum. So it's being introduced now, but you see that we are going to be looking at this concept being mashed up with other concept of what? Of valuation and capital budgeting and financing as well. So it's going to be coming back again and again and again as well. So when you look at inflation and real returns, please take note of this formula, which says, I don't like the way they put the variation there, but I'll give you the formula that I need you guys to take note of. So I'll give you the formula that I need you to take note of, because when they ask you these questions later on, you just need to know the formula and how it links as well. So depends on how they ask you to use it as a discount rate. So usually when you're assessing investments, you are going to be asked to determine the discount rate. And when you're determining the discount rate there, the discount rate can be in a real rate of discount, or it can be a nominal rate of interest when it comes to the discount as well. So take note of this. The real return is given as 1 plus the nominal return divided by 1 plus expected inflation minus 1. So please take note of this formula. Also, if you play around with this formula as well, please take note of this formula as well. The one that says your nominal return can also be given as 1 plus the real return multiplied by 1 plus expected inflation minus 1. So please take note of these two different formulas. The formula for calculating the nominal return and the formula for calculating the real return. Because you're going to be using them later on when you look at capital budgeting, where they say calculate the capital budget, calculate the value of the net present value in real terms. If they ask you to find in real terms, it basically means that they're going to be using the real rate of the interest that they're going to be using is the real rate of interest, and this is how you get it. If they ask you to use the nominal rate of interest, this is how you're going to be getting the nominal rate of interest. So please make sure that you take note of this. Are there any questions? Take note of these formulas. We're going to be dealing with them later on. For now, just take note of them. On the next section, they look at this, some real-world applications. Don't worry much about it, because they'll give you their own case study and they'll ask you to answer questions based on the case study. The next section, which is important that we're going to be looking at, is the one that looks at loan amortization schedules. Reason being, loan amortization, we're going to be looking at it quite a lot when we're looking at capital budgeting issues, and also later on when you're looking at financing issues as well. So loan amortization schedules, and they're also going to be important because we're going to be looking at them later on as well when we look at leases as well. So the loan amortization schedules, please take note of it because it's very, very important. So when it comes to loan amortization, this is where we're saying that you're borrowing money, but when you borrow money, then they ask you, the bank will say, fine, you want to buy a car which is worth 300,000, for example. Yes, we'll give you a loan of 300,000, but you have to make sure that every month you pay us an installment of, let's say, for example, 7,000. So from the loan payments that you're going to be making, what you might not realize is that every time you make a loan payment, some of the money is going to go towards interest to the bank, and some of the money is going to go towards what? Repaying the money that you're owing to the bank, which is the principal amount. So when you look at loan amortization, we're trying to find out exactly, so what is the split between interest payments and principal payments every time you make a loan payment? So to understand this better, they give us that example of Alfa Romeo, right? They give us that example of Alfa Romeo. Can you quickly read through this paragraph and we go through together? So they tell us that you're looking to get to buy a car and you're getting a loan of 100,000. Your interest per year is 7%, and you're going to pay back this loan over 5 years. So you now need to look at the preparation of the loan amortization schedule to find out exactly every time you make a payment, how much is going towards the pay interest, how much is going towards the principal, and how much is still outstanding on the loan as well. So that's basically what we're trying to do when you prepare the loan amortization schedule. So in this case, it would mean that to find the to do the loan amortization, you are going to look at you first have to calculate the PMT. So to do the loan amortization, you first are going to calculate the PMT. Someone is saying that they didn't get the formulas. Let's say R with the star on top is equals to your real return, and M is equals to your nominal return. We're going to be using this R and this later on. So your real return is given as 1 plus your nominal return divided by 1 plus expected inflation minus 1. So your EI is basically expected inflation. Your nominal return is given as 1 plus real return multiplied by 1 plus expected inflation minus 1. So please take note of these formulas. For those who had not gotten the formulas. Going back to our example for loan amortization. So going back to our example of loan amortization. Whenever you do loan amortization, step number 1 is to calculate PMT. Step number 1 is always for you to calculate the PMT. So to get the PMT, we're going to say, we are given that the present value is 100,000. We're also given that the interest rate is 7%. And we're also given that the number of periods is equal to 5 years. So how much do you get as the PMT in this case? How much would you get as your PMT? How much do you get as a PMT? Are you getting 24,389? Are we getting the same amount? So that's your step one. So whenever you do loan amortization, step number one is always for you to calculate your PMT. You cannot amortize without calculating the PMT. Now, step number two, that's when you now amortize. So that's when you now amortize. So when you're amortizing, you need to indicate the year. You need to indicate the beginning balance. You need to indicate the loan payments. You need to indicate the interest due. You also need to indicate the principal repaid. And you also need to indicate the ending balance. So on our loan amortization schedule, we have this is going to be paid over the 5 years. So it's going to be 1, 2, 3, 4, 5. The beginning balance we're originally owing 100,000. So we're originally owing 100,000, and we know that every year we're going to have to pay 24,389. So this remains the same. So you're paying 24,389, 24,389, 24,389, 24,389. So now you need to find out exactly every time I make this loan payment, how much is going towards interest payments, how much is going towards what? Repaying the amounts due, the principal repaid as well. So to see that breakdown, first, step number one, calculate your PMT and do not clear memory. So you don't clear your memory. Then after this, we're now going to say, so if that is the case, it would mean, if that is the case, if you're going to be using the HP calculator now, remember you've calculated your PMT. Then after, if you're using the HP calculator, you now need to find out exactly, so how much did I pay as interest and principal in the closing balance at the end of year one? To see that breakdown, that's when you're now going to say, you press 1, you press the input button, you press 1 again, then you say shift, then you press amort on your calculator. If you're using, then if you keep pressing equal sign, it will give you the breakdown of the interest, the principal, and the closing balance. If you're using the sharp calculator, remember here, you have calculated your PMT. So with the sharp calculator, you just say, you press a MRT button on your calculator, and where it shows you P1, it will indicate, it's already indicating 1. You scroll down, where it's showing you P2, it's already indicating 1. You keep scrolling down, you see that when you continue scrolling down there, it will give you the breakdown of everything as well. Because P1 means the beginning of the period for which you're amortizing, and P2 means the end of the period for which you're amortizing. So if you do the amortization there, you will see that with your calculator, the principal amount you're supposed to be getting there is an amount of 17,000 for year one, 17,389. And the interest due is going to be 7,000. And the closing balance is going to be 82,611. Are we on the same page? Any questions? Anyone lost? The ending balance in year 1 becomes your opening balance for year 2. So your opening balance for year 2 is 82,611. Now, if you want to amortize for year 2, what are you going to do? If you're using the sharp calculator, you keep scrolling down until it takes you back to P1, because P1 means the beginning. Now you want to amortize from beginning of another period. So what you're going to do is that when it shows you P1, for year 2, you're going to press 2, then you press enter. You scroll down, it will show you P2. And when it shows you P2, you're going to press 2 again, and then you press enter, because you're now telling your calculator that I'm amortizing from beginning of period 2 until end of period 2. Then when you keep scrolling down, it will give you the breakdown. Then if you're using the HP calculator, you are just simply going to say 2, you press the input button, then you press 2 again, shift amount, and if you keep pressing equal sign there, it will now give you exactly the amortization for period 2. And you see that your principal amount should be equal to 18,606. Your interest would be 5,783, and your balance will be 64,005. Are we getting the same amounts? Anyone lost? Any questions? So we're going to do the same for year 3 as well. So your opening balance is 64,005. So what are you going to do for year 3? For year 3, with the HP calculator, you're simply just going to say 3, you press the input button, 3, shift amount, and when keep pressing equal sign, it will give you the breakdown. And with the sharp calculator, you keep scrolling down until it shows you P1. And on P1, you're going to press 3, then you press enter. You scroll down. On P2, you're going to press 3 again, and then you press enter. And when you keep scrolling down there, it will give you the amortization for period 3 now. So you see that your principal amount is going to be 19,909. Your interest would be 4,480. And your balance would be 44,096. And your closing balance for year 3 becomes your opening balance for year 4. Are we on the same page? Any questions? Anyone lost?
I think I'm lost. For year 1, I managed to get all the answers. But when I have to go to year 2, I don't know what to do. I don't know.
Which calculator are you using?
I'm using Sharp.
Now, remember you got the interest and then the closing balance, right?
Yes.
You scroll down until it shows you P1 on your calculator.
Okay.
Then if you're amortizing for year 2, you press 2, then you press the enter button. Do you see where the enter button is? ENT.
Yes, I can see that.
So you press 2, then you press enter. You scroll down. It will show you P2, right?
Yes.
You press 2 again, and then you press enter.
Enter. Okay.
Then when you keep scrolling down, it will now give you the breakdown.
Oh, okay. Yeah, now I see. Thank you.
Okay. Any other questions? Anyone lost? Now, to amortize for year 3, so to amortize for year 3, you are more or less going to be following the same steps. Because to amortize for year 3, if you are going to be using the sharp calculator, for year 4, sorry, if you're going to be amortizing for year 4, if you're going to be using the sharp calculator, it would mean, remember, you scroll down until it takes you back to P1, and you're going to say 4, you press enter. Scroll down, shows you P2, you press 4, then you press enter, then you keep scrolling down, it will give you the amortization. And if you're using the HP calculator, it's going to be 4, input, 4, shift, amount, and you get your answers there. So you should be able to get figures of the principal amount for year 4 should be 21,302. And your interest should be 3,087. Your balance should be 22,794. And the closing balance then, you'll be opening your balance for year 5, which is 22,794. Are we on the same page? Then to amortize for year 5, same thing. 5 input 5, shift amort, and if you keep a equal sign, you get the amortization. If you're using the sharp calculator, scroll down until it shows you P1. Then you say 5, you press enter. Scroll down on P2, you also say 5, then you press enter. And when you keep scrolling down there, it will give you the amortization for year 5. So your principal amount would be 22,794. Your interest would be 1,596. And your closing balance would be 0 because you're no longer owing the amount, because after year 5, you have now fully paid the amount due, the principal amount. Are we on the same page? Any questions? Anyone lost? So, preparation of the amortization schedule. Then this whole table, you need to know it. It's going to come back a couple of times, especially when you look at lists as well. So please know how to prepare this amortization schedule. Very, very important. Any questions? The last section of the chapter that we're going to be looking at is to do with theory, because potentially they can potentially ask you theory questions as well. Now, if you look at the past 2 years, the lecturer has structured the exam a little bit differently, where he is now having a situation where one of the questions, maybe you'll be having about 5 or 6 questions, and one of the questions is going to be a short questions. And sometimes they even ask you theory questions now, which they had not done, but over the past 2 years, they have started doing that as well. So look at the financial calculator and spreadsheets. You don't have to worry much about that because we've already looked at it. And you don't have to worry about Excel spreadsheets because we're not going to be using Excel spreadsheets. You're going to be using the financial calculator to get the answers there. Then they also look at the role of interest rates. And here, what you need to make sure that you take note of here is that they say, in general, the interest rate which represent the return required by the lender is influenced by 3 main variables: the time value of money, the risk of the capital not being repaid, and inflation. So potential theory questions there, take note of that. Then from here, we look at the different theories which explains the movements in the yield curve. So we look at the different theories which explains the movements in the yield curve. And what they can potentially ask you there is where they are discussing the market segmentation theory. So where they're talking about, they say the most commonly quoted theories are the expectations theory, liquidity preference theory, and market segmentation theory, because they can potentially ask you these as theory questions in the exam or assignments as well. So you look at the expectations theory, they say, assuming an investor is faced with the choice of investing a sum of money for 1 year in a bond at interest rate or 5 years in a 5-year bond, which alternative will be chosen, right? So please take note of this. What you need to know about the expectations theory is that the expectations theory basically states that the yield curve, remember the yield curve is what shows you the relationship between the interest rates over time. So this is basically a typical yield curve because it shows you what interest rate are you expecting going into the future, which is over time, from time to maturity as well. So what you need to know about expectations theory is basically looking at the expectations of how the yield curve is going to play out going into the future. If the investor is expecting interest rates to go up in the future, you're going to have what? An upward sloping yield curve. So we are saying, in general, when you look at the yield curve, so in general, when you look at the yield curve, it shows you the yield over time. So it shows you the yield over time. So we're saying the yield curve can be upward sloping, or it can be generally flat, or it can be downward sloping as well. So if with the expectations theory, it's just saying if the investor is expecting interest rates to go up in the future, the yield curve will be upward sloping. And if the investor is expecting interest rates to remain the same going to the future, the yield curve will be flat. And if the investor is expecting interest rates to decline going to the future, the yield curve would be downward sloping. That's basically what the expectations theory states there. So the expectations theory basically looks at the expectations of what is expected when it comes to the interest rates in the future. If they're expecting high interest in the future, the yield curve is upward sloping. If they're expecting the interest to remain the same, the yield curve will be flat. And if they're expecting the interest to be downward sloping, then to decrease in the future, then the yield curve would be flat. Then the liquidity preference theory basically says for deferring and consuming their money now, or for deferring accessing their money now, investors want to be compensated for that. So what does that mean? The liquidity preference theory basically says that the longer the investors are having to defer getting their money, the higher the interest rates. So what does that mean? The liquidity preference theory follows an upward sloping yield curve. So the liquidity preference theory, it follows this yield curve here, because it's basically saying that the longer the time it's going to take for them to get their money, the higher the interest that they expect on their investment. So that's basically what the liquidity preference theory is trying to explain. Then there is also the market segmentation theory. So with the market segmentation theory, they are basically saying that investors belong to a particular market segment, and there is no enticement for them to move away from a certain maturity. So they are basically saying, if you have an investor who's expecting to invest for a short period of time, the yield curve is going to be based on what's happening during that short period of time. And if an investor is expecting to invest in the medium term, the yield curve in the medium term is going to be dependent on exactly what is happening in the medium term. And if the investor is expecting to invest in the long term, the yield curve is dependent on exactly what is happening for long-term investments as well. So which basically means that there is no enticement even to increase the interest rates for investors to be attracted to invest in the longer term. Like, for example, if you know that you have 10,000 rand that you want to pay for fees for your child, let's say, for example, you have 100,000 rand that you know that you need to pay for fees for your child next year. That event is inevitable, which basically means that whether you are offered a high percent of interest rate, you still have this commitment to pay your fees for your child. So which means that you are going to stick to the investment horizon, whether you are offered higher interest rates, because what you need that money to meet a particular commitment. Because which means that investors are basically going to be sticking to a particular segment as well. So which means with the market segmentation theory, they are basically saying that the yield curve is going to be dependent on exactly what maturity segment the investor is going to be finding themselves under. That's basically what the market segmentation theory is going to be saying there. Are there any questions when it comes to the theories? Any questions? Section 6 looks at applying term value of money to principals or bonds. Don't worry much about it. We're going to look at it in detail, and when it makes more sense in chapter 6, where we look at valuations. Where in chapter 6, we're going to be looking at valuations of equity and valuations of debt financing. And one of the debt financing is where you are going to be finding what? Bonds. So you just take note of it, but don't worry much about it as well, because we're going to be looking at it in detail in chapter 6. Are there any questions on what we have done today? Any questions? All right, if there are no questions, enjoy the rest of your weekend. Please take notes. I'm busy compiling the dates of the due dates for the assignments as well, so that we make sure that at least a month before the first assignment, or a few weeks, couple of weeks before the first assignment is due, we're going to be looking at the assignments as well. All right, enjoy the rest of your weekend.